Hello and welcome to this tutorial on creating pre and post-synaptic surfaces for SynAnalyzer from ZStacks. There are a lot of assumptions made here about what your ZStacks are like. This tutorial is specifically for the type that we acquire in the Goodrich Lab. So we're starting out with our CZI files that were acquired on our Zeiss microscope. And these are just some representative images that I chose at random to use for this tutorial. So the first thing that we need to do is to convert these using Imaris file converter. This is something you're probably familiar with already. And so you can just click and drag the file into the converter. And then for the output, it's good to make sure that you might want to use the same folder as the input folder. Sometimes it can end up in some random person's folder. So then you just hit start all and it goes through the process and we see our nice output there. Okay, so then we can close this and then we're going to take that Imaris file and open it in Imaris. You could double click. This computer has two different versions of Imaris installed, so I'm just dragging and dropping to make sure it opens with the latest version. Okay, so immediately you'll notice that the image looks very contrasty, and that's because Imaris automatically adjusts all of uh, the channels when it opens a new file. So we're just going to reset those channels, and then we're going to turn off everything except for our presynaptic marker channel, which is typically in 488. And then we're going to save this as is. We're going to have that general principle of constantly saving our work to make sure that we don't lose any work. All right, so now we're going to make our presynaptic surfaces. So we have some presets that I made in Imaris that we're going to lean on to help sort of speed up this process. So we go to add new surfaces, and immediately I'm going to rename this as presyn. And then I'm going to choose my presyn settings and then click through. So the presets for the presynaptic marker will auto-populate for each page that we're going through in the creation wizard here. So, you can try playing around with these if you want. I spent a lot of time tweaking each one of them to try to see if it would improve things or not. And just sort of settled at what was the best I could get it. So next we're going to click on threshold, and you can see that it does a fairly decent job, and that it mostly gets all of the surfaces, or mostly gets all of what look like real puncta. There's definitely one that's missing there. So the preset has auto-selected. So you can also click and drag this to make them, to change the thresholding. I highly suggest the auto setting, but there are going to be these cases where it's going to miss some, and really your only option is to sort of increase that threshold just a little bit. And then you'll notice that we also have morphological split enabled here because inevitably there are puncta that just kind of get blurred together, and unfortunately this is the best we can do in terms of trying to break those puncta apart. So then we're going to filter seed points. I didn't really find any of the filter settings to be super helpful for these types of images. Maybe you can play around and find something different. Then in terms of volume, I set this lower limit as pretty low because I noticed, and you can even see here, oh, we lost that guy. Let's see if we can bring him back. Yeah, So you can see there that um, unfortunately some of those puncta can look very real, so we don't want to exclude it, but they're also extremely small. And if we try to grow that surface by increasing the threshold, it would actually make this clumping even worse. So there's this constant trade-off that we're playing to try to get it as good as we can get. All right, so then the surfaces are created. That's the best that we can do with them at this step. So we're just going to finish that. We're not assigning surfaces to each hair cell. But now what you do have to do, and actually you want to stop and save really quick. What you do need to do for SynAnalyzer is turn on your hair cell mask. You can turn off the marker channel if that helps. And you have to delete any surfaces that don't belong to a region that you're specifically looking at. Sorry, so like this hair cell in particular, for instance, this hair cell is kind of on the border, and we can't really see there. Some of these synapses may or may not belong to that hair cell. So we're just not going to include that hair cell in this analysis. And so what's important for SynAnalyzer is that you actually stop and delete these. So to do that, you're going to go to Edit. Sorry, wrong tab. Edit. I've already selected them, and I'm just going to delete them. Okay. And then I'm going to do the same thing over here. For SynAnalyzer, you don't need to worry about these ones that are really outside the area of interest, because in SynAnalyzer, you're going to create a bounding box. You're going to draw a rectangle around the region that you want to analyze. And these little guys are so far outside of the area that you will definitely be drawing a box around that you can just ignore them. But then what you do have to do is start the painstaking process of splitting up any puncta that clearly don't belong to each other. So, for instance, I mean, you can see them all over the place here, and I'm just going to do one to get us started as an example. But so yeah, let's talk about those guys here. So we should be able to straighten this out. So unfortunately, this process is a little challenging in Imaris. What you have to do is actually, your cutting plane is always going to be perfectly vertical. So I'm holding down the Shift button and then clicking with the left mouse. So you can see how that blue line, that's where it's actually going to split those two surfaces. It's, you know, it's challenging to try to get it perfect, but you can always redo it just by holding down Shift again and just clicking again, and it just redoes it. And then you go over to Cut Surface. And so you do want to go through and do that for all of the surfaces that are clearly, you know, two ribbons connected. And that's really where this process can take a little bit of time. So we're just going to skip ahead and pretend that all of those are done. But obviously you can see there are a few more here. I will just stop for a moment and say that this is where your image acquisition settings can really make or break, or make this process a lot easier or a lot harder. So as you're kind of looking at the image here, you can sort of see this like faint glowing around the puncta. That faint glowing is really what makes the the segmentation algorithm fail. And so even though we have background subtraction, so we're trying to reduce as much of that faint glowing as possible, the fact that there is that faint glowing is what is making these clump together. And so something you can try is reducing your laser power here. Obviously, it's hard because if you reduce your laser power even more, you're going to lose things like that guy. So this is kind of where, you know, there may be some back and forth between your image acquisition and your analysis to try to see like where is that sweet spot. But generally, trying to reduce these little halos during the image acquisition step will reduce the number of cuts that you need to make in order to break up these puncta. But I'll just reiterate that it is a trade-off, because if you underexpose them, and if you're trying to analyze their volumes, but they're underexposed, you could be sort of reducing their volumes inadvertently without really trying. So, all right. Once you have your synapses or your presynaptic marker surfaces all made and you're happy with them, you need to export your statistics. And normally you can click on preferences here if you want to configure this list of what is being exported. For some reason that's crashing the shared computer version of Imaris right now, so we're not going to do that, but that is something you can do in the future. You're just going to export all the statistics for right now. And again, for the purposes of SynAnalyzer, you're going to add XYZ. So this is the image name, and then I'm adding XYZ and presyn. This is just notation that SynAnalyzer expects to see at the end of this Excel file. And save. And then it's going to open up. So if you wanted to, you could just go through here and double check the position and volume. There's a lot of stuff that's getting exported here, but I want to show you really quick the stuff that we care about. There it is. So yeah, position is the page that we care about, and these surface IDs are important because that's what SynAnalyzer is going to use when referencing each of these surfaces. All right, so that's our presynaptic. Now we're going to go ahead and do our postsynaptic. Save that again, just in case, and then turn off that channel. Turn on our presynaptic marker, postsynaptic, sorry. Turn off our presynaptic surfaces. And you can see this looks really dim, which might make it hard to verify or validate what is being segmented. So, you know, you can adjust this display to help you see better. But the reconstructions, the surface reconstructions are going to be based off of the raw image. So you're not actually changing anything that that Imaris is using. A quick note right now, really quick, is you can tell that this region was photo bleached a little bit because you can see how on the edges here, it's really, really bright, and then on the center, it's really dim. So that's a good sign that this area was probably imaged multiple times. So we can hit reset just so that we're going to make that stop floating. And now we're going to create new surfaces. And here, kind of similar to the presynaptic game, I made some preferences for some default parameters for the postsynaptic marker. Click OK. This is the best that I could get it in my hands. And then here you can see these little surfaces start to appear. And yeah, it's interesting in this image because this region was bleached and that region was not. As it's using the presets, oh wow, that's the automatic threshold, yeah. There's a little bit of a disconnect there. So for stuff like this, you probably will need to adjust that threshold. And it's just going to be a judgment call of terms of where do you think is a good cutoff and what's not. And you know, you're probably starting to appreciate some of the limitations of this type of analysis in terms of you know, how accurate can you really be with what types of volumes you're getting from these postsynaptic markers. Something you can do, since this is an example where, you know, you probably still want to use this image, but you have this issue with the different regions, one being photo bleached, the other one not. Like, this isn't terrible, right? Like, you can still see the signal. It's still real. It's just not as crazy bright as that one. Something you can do is decide to maybe eliminate these hair cells, whatever hair cells are underlying those markers, from the analysis. So, okay, so you're doing your threshold and you're just going to try to have to tweak it as best as you can. You know, and here this might be helpful to turn on your hair cell mask because that is going to help you identify where are these actually, which of these puncta actually belong to the hair cells, rather than just kind of being general debris. And then use your thresholding to take it down. So I have to stop it there because I see that that little puncta looks real, and I want to make sure that I get it. But if I go any lower or higher, so if I go higher, I'm getting just mess. Right. Okay, so that's about good. And then click forward. Okay, and again, there's a volume cutoff here, so hopefully we get everything. Okay. And then you're just going to do the same thing that you did for the presynaptic marker. It can be really helpful here because some of this debris is getting really close to the hair cell. In these cases, you probably do want to delete this. And then the other thing you do need to keep track of is, well, I guess in SynAnalyzer, you'll see where the rectangle box is and how many hair cells are included. So it can be good to keep track of just how many hair cells you're including in the analysis. So here's where the thing I was talking about earlier, where we can see that that bleach line is happening right across this hair cell. So some of the synapses are one level of intensity. Some of the markers are one level intensity, and then some of the markers are a totally different one. So what you can do is say, hey, I'm not going to include that hair cell in the analysis. So I'm just going to delete everything that's associated with it. And then obviously that's not, this region here is not around our hair cells. So it can be really helpful just to go ahead and delete all of that sort of extra stuff. So once that's done, it's the exact same process as before in terms of exporting your statistics. I'm just pretending like I've finished cleaning all of this up. So I'm going to export all those statistics to file. Here, though, I'm going to say post-syn. And you can see there's a just crazy number of surfaces here because I didn't actually clean them all up. But just for illustration purposes, this is, again, what you do for exporting those surfaces. So in summary, these preset, and sorry, I didn't actually rename this, but it is good to name these surfaces and save the file, save the Imaris file, just in case, because in order for someone to see how you got to where you were with these surfaces, they'll need to review that Imaris file. So it's good to save that Imaris file before you close it. And yeah, it's still a lot of work to go through and make sure that each of these are broken up properly. But hopefully with these presets, with the parameters that are stored, hopefully that cuts down some time. Thanks.